a broad theme of a lot of things that I've done is about putting everyday observations into systems. So it's like you see something, you notice something interesting, see if you can make an algorithm out of it and put it into it and eventually make money, right? So that's how I've been looking at things. I also got a PhD along the way, doing stuff like that, work at Google for a while, and then doing startups. So today's talk, I hope it will light up. It is something that you're all very, very familiar with. We kind of take pride in a fantastic system that we've built here. But at the core of this is simple observations that we make around us, right? So what I want to do is, if like the real takeaway that I'm trying to drive is, if there is something that you notice and you see a pattern out of it, there's a possibility of like creating wonders by taking it to broader scales, right? So that's what I want to drive in, and we'll go a little bit deeper into like how this came about and what happens when you try to adapt an everyday observation into a system, right? So it will be mostly non-technical. So I do not assume you to have any knowledge of computer science, or of course, if you do have, you'll have a lot of questions. We're happy to take that. But these are like very, very simple things that you can tell a kid. And what's interesting is most successful companies that you see out there are based on such simple observations, right? So the famous example is Google itself, right? So I'll give you, how many of you are from the an IT background or a computer science background? That's heartening that there are people outside of this. But so think about this. So the whole of the Google search engine is based on this simple premise, right? Where say we have this crowd, and I ask you to point like your finger at somebody that is good. Okay? I ask you to point your finger at somebody that is good. And you'll all do that, right? So you'll say here, and right? You'll say, hey, this person is good, this person is good. Just take that, right? This is something that people always do. You go ask people out and say, like, is there a good eatery? They'll say, yeah, these are the 3 good eateries, and so on. Now, visualize this place itself, where you're all pointing fingers at, like, you have 2 fingers, 2 hands, you can point it at 2 people, that's all, right? And you're all going to be doing that, okay? If there is some celebrity here, then you will notice that you have only 2 hands to point at people, but when there's a celebrity sitting here, a lot more hands are pointing towards this person. Right? It's natural observation, right? Because you are like, I like this person, I recognize this person. So you just analyze how many hands are pointing at a given person, right? And then you have a simple way of finding out who's popular, right? They just applied this on the web, right? And built a whole search engine on that concept, right? So they called it as PageRank, and right? So this field of information retrieval, it's a formal name for that, is about how you can use concepts from ultimately sociology to improve the way people get access to information. Right? So I'm going to like talk about similar such observations that we came across while we were doing our work. Quick detour into television, right? So I'm sure all of you watch television. So of course there comes a time in people's life when their TV watching dips, and then it comes back up, right? So from the demographic that I see, a lot of you are like, oh, who cares about television? But maybe there's a cricket match, you'll get back to that. There's one show a week, you'll get back. And some of you will be like, I do watch TV, but I do it on demand. I go to my Netflix or something like that. What happens is, through a person's life, so kids, they end up watching quite a lot of TV, and they do not watch on-demand TV because so mostly parents like put a channel that they think that is fine for them and leave it from there. Then teenage slowly kind of comes down. Then you get married, you do your house, and then you buy your first big TV because it's a living room. Interesting thing. So if you are on your mobile, if you're kind of married or things like that, if you are on your mobile and your spouse is in front of you, both of you are looking at your mobile, you are angry at each other. Have Have you had this fight where, at least I tend to have, because mobile is considered a personal time, but television is not. Both of you are simply wasting time, right? You're watching your Facebook, she's watching her Facebook. Both of you are watching time. But if both of you waste the same time watching a big screen on TV, it's considered family time. Okay? So when people start doing families, they like the TV consumption slightly goes up and peaks for seniors, right? By the time they're 50, 60, 70, right? And all the statistics are astounding. So the average household in India, there are 150 million households in India that watch television. Okay, what's the average TV duration that every day? Right? So it's about 2 to 3 hours, right? So, and I'll give you a comparison. Like Facebook is very popular. What's the average session duration? The term for this is session duration. So, what's the average session duration of Facebook? 20 minutes, right? So you're seeing this. That's the scale of how much bigger television is compared to the most popular thing that is existing, right? So all of you, if you're not watching TV now, you'll end up watching TV, right? So it's that. Now the question is like, why do you need to know what's coming on TV? As a consumer, and when I say, why do you need to know what's coming on TV? What goes through your mind? What is that what part here? What is coming on TV? What does that what mean to you? Any thoughts? So what do you need to know about what's coming on TV? Something new then? Like you want to know if there's a game that's coming, this particular game is coming. So when we want to know what's coming on TV, it's not just for knowing what to watch, it's also for knowing what not to watch. Right? Example is like, a lot of people are like, hey, I don't want to watch a show when there's an ad break on, right? So you care about knowing if there's an ad break on because you know what not to watch on TV, right? Or if you have kids, you want to know like there's like an adult-oriented scene that then you don't want to be switching to TV at that point in time, right? Or you want to know what's coming on TV because you're like, is there good music coming? Is there my favorite star that's coming? There are people who are like, every time Katrina Kaif comes on TV, I want to catch that glimpse, right? They want an application that can tell them like, hey, she's on TV now, go switch to that channel, right? So, and your current day TV experience is not like this, right? So it's not this fine-grained. You get things at a very high level. Okay, this game is on, this show is on from here to here, and so on. This is you as a consumer. Now let's go to the other side, like the industry, the TV industry itself. When I say TV industry, not just people who produce shows, also people who pay for something to come over there, like the advertising industry. Why do they need to know what's coming on TV? Because they need to know who watched it, and they need to know who did not watch it, right? Now, say you're a TV channel and you've acquired rights for playing this movie. You played this movie out. You want to know how many people watched it, how many people did not watch it, right? So, and then in this movie, you had certain ads that were playing. Now, the advertiser there wants to know who watched it and who did not watch it. Both these problems, whether it's for a consumer or for somebody from the industry, the core is you need to know what's coming on TV. So we are building that system. We are building a system that accurately knows what's coming on TV. Let me define what is TV. There are a bunch of shows, but what's coming on TV is not just shows. You have, let me go a little deeper. There is a show, say Saath Nibhana Saathiya, that is coming, but the show could be in different moments. It could be in its title scene, it could be in credit scene, it could be in an ad break. If it's in an ad break, a certain ad is coming, right? There could be a certain song that is coming, there could be laughter in this, it's going through so many different moods. Then your lead actor may be here. Say you're doing Kapil Sharma show, you've just got Jacqueline Fernandez on screen. So when you look at TV, it's going through all these moments, right? And then if it's a news channel, you're talking about certain topics, so it jumps between topics. So our notion of deep television is to build a system that simply knows what's happening on TV at this fine-grained level. Right? We want to know Salman Khan is on screen right now in the 6 channels. So we want to know the topic of demonetization is being spoken in these 4 channels. So you would say like, why build it? Isn't all this data available? So the interesting thing is, if you look at a country like India, there are probably around 800 channels in all. And the way TV broadcast happens is, so an advertiser comes, gives like, I want these ads to be played between these times. Then you have your editor who comes and says, okay, these are the shows that I need to be aired at this point in time. There's a guy who's doing this playouts, right? He's this mixer. Think of him as a DJ, right? So the DJ for TV. And he's mixing all of this stuff and throwing it out, right? Only he knows what he's played out. And that record does not go out of the TV channel. It's not available to your Tata Sky and others. It's not available to consumers. It's just lost. So information is lost about what exactly got played. Now, can you build this information? Right? So that's the high-level thing of like what we call as deep television. So I told you about like when I say what is exactly coming on TV, it could be an ad, it could be a song, it could be a title credit, it could be a star who's on screen, and so on. So I'm going to talk about how we built a system that just tries to figure what ads are coming on television. We run this site called adbreaks.in. This is live ad break status. Right now, if you were to switch on TV and run through like all these channels, then we know that you can see it's changing, right? So 28 and it's 10:16. So generally, just past the hour, the ads are the fewest. But around this time, around the quarter past the hour, or the quarter past the half hour, ad breaks tend to peak. So you can see that it's actually increasing right now. Nobody told us that like ZTV is playing this. Nobody told us that this is playing this, right? So, and we built this system. Over the past week, we've had like 10,000 such ads that we automatically said, hey, these are ads that are playing on TV. This week, there were 380,000 playouts of ads. So what's a playout? An ad played, okay, across all of these channels. So if you actually count every time an ad played on television, across 239 channels that we were tracking, there were 380,000 ads that were played. Right? You see the scale of this? What's interesting is only 10,000 creators were played out. So 10,000 new ads. And some of you are from the creative domain here. You've made ads and so on. So this is how it gets consumed. 10,000 ads are actually repeated so many more times. When do you think the Skoda Rapid app ad is going to be shown? Who's the decision maker for this ad? Kids? Kids are decision makers for a car? So who decides the car that you buy? Yes, the main guy who's earning, right? And when does he watch TV? Right? He comes back and let's see if this pattern is there. Right? You see that it's so much more skewed. They are not at all spending any money through the day. They're like, I am just going to spend money around prime time. Ads are short. They're always short, right? So you don't have a 30-minute long ad. They're heavy on audio, right? There's a lot of audio. We'll make use of this in some sense. This is what's annoying about them. But this is the thing that reveals what an ad is. Right? It repeats a lot. Right? They always come together. It's an ad break. That's why it's called an ad break, because all these ads are like, hey, I'm going to show like one after the other. Okay? So these are observations you can make too, right? Like how about, and this is the core of our system. To do any of this, we need access to what's coming on TV, at least the audio, the video, and all this. So we have an ability to see the multimedia streams that are coming across on ads. It can happen by, you can do it at home. You just like take, instead of one set-top box can give you one channel. You have an array of set-top boxes, let's say, get 10 from your provider, you have access to all of them. Feed it to a computer, you get multimedia streams for them, right? So that's how we started as well. So think of this as a channel stream. It's all the audio, video that goes through a given channel. let's say this is star plus, right? So then you have one more, which is ZTV, right? So you have all of them like this. What's interesting about an ad is based on those patterns that we just talked about. An ad is some sequence that comes over here, okay? It's a short sequence, like which is probably 6 seconds to a minute, right? But there are different variants. But the same ad comes elsewhere as well. On a ZTV, same ad comes again on a Star Plus at different times of day, right? And if I can use a different color, this is a different ad here, and here it might come before this, here it might come before this, here it might come before this, right? And you have many like this. So what we did was, we looked at it as, suppose I just start analyzing these streams and see if something repeats. Something repeats that tends to be having these characteristics. It's short, it runs from like 10 seconds to a minute, tends to repeat, they all kind of come together, right? And they also come across channels, right? And the more they repeat, the better for us. So we built a system that exactly takes these observations and puts them into an algorithm, right? Just use some terminology here. So this is, it could be audio or a video, but since they're heavy on audio, audio processing is always cheaper than video processing. Video, you have to look at more images. So we figured out a way to convert audio into numbers. There is a standard method called, the term is called acoustic fingerprinting. But let's say there is a sequence of audio. There is a way to convert whatever that sequence is into a signature for that sequence and come up with a number. So what this meant is, all of these were numbers. You had like some like 0, 1, like some binary stream over here, some binary stream over here, right? All of these numbers, right? And then we have to look for these patterns. So what we did was, we looked for repeating number sequences out of TV. So we store everything that goes through television for like about a week, and we constantly keep analyzing for, are there such repeating numbers? Are there such repeating numbers? Okay. And you do get such repeating numbers. And the more they repeat, the higher the possibility that it looks like an ad. There will be false positives, right? Think of examples of non-ads that also end up coming into the system. Ad for TV shows. Yeah, they're called house promotions. Yes, they would also come in. News clips. Yes, news clips will also come in because they tend to repeat the same news clip again. Something else? Trailers for movies. Okay. Music videos. Yes, great one. What else? I'll tell something that will make you laugh, like fake laughter. All these shows that you're supposedly comedy shows, they all put fake laughter. Right? And they will keep coming back because the same sequence, they just play that audio out and it keeps repeating, right? So all of these are things that are not supposed to be ads that also keep coming in. And we need to figure out a way to call fake laughter as fake laughter, house promotion as a house promotion, and any ad that you see, you look at the last frame, there's something about it, right? So the ad will start out somewhere else, but they always converge towards showing brand logo, okay? So this is a great giveaway, right? So if you just analyze ads and look for certain of these frames inside the video, then they're kind of giving away to what the ad is. Now, this was like, you cannot have an algorithm for this, but why is the last frame like that? Yeah, so when you like part ways, you want to like, you want to showcase the brand and have a parting message and say, this is what you need to be thinking about when the ad ends, right? And that last frame takes a lot of design. They put a lot of time into getting that right. And all ads are going to do a great job of this. They'll always ensure that this last frame is shown. Okay? That's a great giveaway, right? For us to know, if you just look for the last frame, then you can quickly identify if it's an ad or not. So we built a system that every day when we figure out a new type of an advertisement, it just tries to show the last frame over here. Okay? And we employed like 2 people that just see the system on an everyday basis. And if something looks like an ad, right, you will quickly notice it because you will see that last frame and you know if there's an ad that's coming up. The people that are coming up on screen are all heavily decked up. They are like good, generally good looking people. That's why they're on TV. So we use an algorithm to figure out all the frames, right, every individual frame, and do face recognition and see if these 2 frames have the same person. Okay, so look at this. So this is one particular show from Ye Hai Mohabbat Hai, and all the frames which have this Sumit Sachdev have been tagged as such. You'll see different poses, different scenes with one guy, all getting clustered together. Yes, we do get the name at a high level from the EPG. It's called the electronic program, right? We know who the actors are, and we do get it at a good high level. Sometimes we do not get it. If we do not have it, we call it as, label it as anonymous. But it nevertheless still is able to get these things together. This is again a real-time system. I'll show you one more example of this. Siya Ke Ram, right? So all screens with like Hanuman come together. So you get all of these things clustered together. Now, is there something about house promotion that you notice? This is very clear, right? I know when we don't have an ad break, and I'm looking at this, I have a lot of people's images that are coming through, right? Now you look at a house promotion. A house promotion is tomorrow's Siya Ke Ram's trailer that is shown today. It's going to feature a lot of these people, right? What else are you going to show in the house promotion? So what we did was, we looked at these candidates. Looks like an ad candidate. So you know it's an ad candidate because it's like 30-second but there are frames inside these that tend to match with actors from a show that runs on TV, right? So the same matching algorithm kind of extends and says, hey, these are all people that typically come in Siya Ke Ram, right? So now you still had this case of an actor may be coming in an ad, but will all the actors from Siya Ke Ram come in that ad? No, right? Just one person. I mean, it's going to cost them a lot to pay all these actors, and it'll look like a promo for Siya Ke Ram and not for the product, right? But the key here is we started using everyday heuristics, converted them to algorithms, and then you start looking at them. First cut, there'll be a few things that works. Second cut, a few things will not work, and then you have this full system that's kind of deployed. Now, uses for these, right? So it's like all of these queries are possible now for you. You can say, like, take me to an English movie that's not in an ad break right now, right? Or you can tell your TV, whenever Salman Khan is on screen, like, send me a notification on my phone. If such systems are made possible, and an advertiser in fact gets metrics for how many people have seen that across the country from which different places, because currently that information is also lacking. So that's the core system here.